Hello, and welcome to Lesson 1.5, Interpreting Distance Time Graphs. Distance time graphs are easy once they're understood, so let's begin with a general breakdown of the different parts. Really, when it comes to understanding time distance graphs, it's understanding the different pieces, the different parts, and what the context is telling you or the graph is telling you as you're progressing through the graphs. So let's take a look here. This is going to be just our standard graph. We'll be working in quadrant 1 with two axes time, excuse me, which is always going to be along the horizontal axis. Time always moves forward and never stands still, and you can never go back in time. So when thinking about a distance time graph, we're always looking at how time is always moving in this direction. Even now, time is passing by as we're talking. Um, Distance from home, just distance. This is depending on the context here. Many of the what we're going to look at today will be distance from home, just because that kind of gives you a reference point. So as you go to the store, you're leaving your home, um, you're at the store, and then you're coming back home. Whenever you're here along this bottom axis, or the value would be 0, your distance from home is 0. Oh, excuse me, I have a bit of a cold today. So our distance from home can change, and we can go from home, leave our home, and always come back to our home. Where in time, we cannot start at, let's say, 12 o'clock and come back to 12 o'clock. That's just not possible when we're talking about that. So here's an example of a graph. It's a distance from home versus time graph. Uh, any of the times that our lines are going up like this, we're getting further away from where we started, um, or our home or our base or whatever it is that our 0 is. When our graphs are going down, we're always getting closer, so we're heading towards that position. And when we have a horizontal line, we are neither further or closer to home. Um, we're just kind of staying still or holding constant at that time. So if we were to kind of interpret this graph we start here at time 0 and we are at home, the person is getting further from home, so they're traveling somewhere. At this point, it's just one point in time. It's decided that, oops, maybe we forgot something or we need to go back home. So we need to turn around and go back home. Do we get all the way back home? Yes, we get all the way back home. At this point, I just picked something up quickly. I'm not at home very long at all, am I? So once again, I'm going further from home. At this time, I have arrived there, or I'm somewhere. I'm not getting closer or farther from home. Time is still moving. I'm just position-wise staying still. And from here, I'm going at this point then in time. I decide, well, I guess I need to go back home, so I go back home. I'm getting closer and eventually back at home. So a possible contextual situation might be I'm picking up my friend John at his house for school. His house is farther from school, so I need to go to his house. I pick him up. Oh, I forgot my science project. So I run home, quick grab it. We get to school, we're at school, and then I drive home. A possible context for that could also be going to the mall. Oops, I forgot my wallet. Decide not to go to the mall and just go to the grocery store instead. I'm at the store, and then I'm back at home. Many possible contexts for this one scenario. So let's take a look here. Uh, what we're going to do is understand Billy leaves home and goes to school. He gets to school and remembers it's Saturday, so he goes back home. Once home, Billy goes to play basketball at the park. He plays basketball for a while and then goes home. So we're given a context. We need to create the distance versus time graph given this context. So the first part I'm going to be looking at is really just breaking down this context up here, this paragraph, into the different pieces and parts that tell us about it. So the very first thing being that Billy leaves home, so I know where I'm starting. I'm going to be starting at home, and I go to school. I get to school. Then what happens? Am I there very long? No, I remember it's Saturday, so he goes back home. Oops, I made a mistake. So now I'm back at home. So time has gone by in my traveling to school and back home from school. Once home, now what happens? Well, I decide, well, I'm already up, so I might as well just go to the park to play some basketball at the park. Am I at the park for very long? I'm there for a while because I'm playing basketball for a while. So I'm not given any numbers down here. I'm just told that I'm there for a while. So I need to be constant at the park for a while. And then I decide to go home. So I just have my line going home. So once again, to break this down, I'm starting at home. Billy leaves for school. He gets to school, remembers it's Saturday, and goes home. Once home, decide to go to play basketball at the park, plays basketball for a while, and then goes home. Now, if I'm looking at this graph as a teacher and I'm trying to tell whether or not you've graphed it correctly, because there could be many ways to graph this, I would really be looking for this point right here, in that he got to school and then went back home. Did he make it back home? Was he at the park? And did he end at home? Those are the main parts that I'm looking at. Also, does he start at home? Those are the main parts of the graph that I'm looking at because it doesn't say that school or the park is further or closer than one or the other. So this line could have gone up to here. I was at the park and then I went home. It could be drawn many different ways. So just the fact that it could be done in many different ways means that as a teacher, I need to be accepting of multiple responses. So for possible correct answers. So let's take a look at a graph now and see if we can pick out the context that it goes to. So given this distance from home and time graph, which of the following could be a description of the graph? So I'm looking at the pieces and parts here. It looks like I'm starting at home. I go somewhere, I come back home, I go somewhere else, and I'm just kind of there for a while. So let's take a look here. Choice A, Veronica trampled up 2 hills before she got to the store. Veronica comes home to get her coupons, goes to the store, and comes back. Veronica realized she forgot her coupons. She returns home to get them before going to the store. Veronica goes shopping at 2 different stores. They both happen to be the same distance from her home, and both A and B are correct. Well, I can take a look here and say, well, Veronica trampled up 2 hills before she got to the store. This graph does kind of look like hills, but we don't really know anything about what she traveled on. We just know the time that she's traveling. So anytime it kind of says that she went up 2 hills or climbed a mountain or fell down into a ditch, that's kind of a distractor, and that's not going to be the correct answer. So I can get rid of that. I can also get rid of both A and B are correct now because I've eliminated A as a possible answer. So what else do I know? It talks about coupons here, 2 different stores that both happen to be the same distance. Well, she went here, but then somewhere else, a different distance. So I'm leaning towards D not being my right answer. So it's either going to be B or C. So as I look at this graph, I'm leaning towards C in that she realized she forgot her coupons, returns home to go get them before going back to the store. The only difference between B and C is really this last line here, and comes back. Anywhere in this graph does she come back home after going to the store? No, she's just kind of at the store. So it ends there with C being the correct answer. Alright, here's another graph with an explanation, possible explanation. I'm going to give you a moment here. If you could please stop the recording and determine which would be the correct answer. And I'll check back in momentarily. Okay, hopefully you've had enough time. So which of the following could be a description of this graph? I have different graphs here. They look like they go to about the same distance. This one, though, is taking much longer to get there. It's taking this whole amount of time here, where over here to travel that same distance only takes maybe half the amount of time. So what is going on in this situation here in this graph? So when I look at this, I'm noticing that block 1, it looks like I'm riding my bike around the block twice. The second time, he goes twice as fast. So you can kind of see here, so during block 1, it takes twice the time as block 2 while still going the same distance, so that distance doesn't change. So it took me this amount of time to go around the block, and then that amount of time to go around the block. Do I have a value for that time? Could this have been 10 minutes and this have been 5 minutes? Possibly. It's just that I know that I'm going the same distance in a far less amount of time. Here's another situation now. Let's sketch the graph. And it talks about how Doug runs around the track 3 times. Each time around it takes him twice as long as before. Sketch a graph of the trip which shows the distance from the starting line and the time. So as I think about this graph, I'm going to have to always make sure I label my axes. So I have time here. And what am I making a graph of? Distance from the starting line. So I'm going to want this over here to definitely be distance from, it kind of tells me exactly what my axes are going to be labeled. Starting line. And I have time down here. I don't know if those are feet, minutes, seconds, whatever. It could be a multitude of things. So as I make sure I label my axes, I know that my distance, however far I travel, it's going to be the same because the track's distance around the track's not going to change. It's just each time it's going to take me twice as long. So that tells me that I'm slowing down. So I'm going to start by going very quickly, which means I'm going to need a very steep line. Now, can I draw a line that goes straight up? I know I'm just making a sketch here, but is it possible to have a line that goes straight up in these types of situations? The answer is no, it's not. Because that would mean at this moment in time, right here, I'm at all these different positions. And it is not possible for me to be at all these different positions in these distances from the starting line at this one moment in time. So it's not possible to have vertical lines. So if my sketch is not accurate like that, then I want to make sure I get that changed and I get that fixed. So let's take a look here at a possible graph. So if I'm sketching this graph, I know that my distance is not going to change. It's just the amount of time it takes me every lap around the track is getting twice as long. So this gets doubled, and then here this is the final double. So once again, if I was looking at this graph and I was trying to grade it, I would want to make sure that these points right here are all at the same distance, that you've labeled your graph correctly, that you're always come back to that starting point, and that this is about half of that, which is about half of that. Just would be looking for those types of things on that graph. Am I going to get a ruler out and measure these? No, but I want to make sure that you understand that it takes him twice as long as before.